So I have it's 2:30, so I think we might as well start. Let me start the recording. Actually, we're still recording here, Jonathan. I'm going to stop it and start it.
I went ahead and stopped it and just started it, but you
All
can
right.
do it again if you'd like.
But it's good as me. As long as you're recording, I'm fine. All right. Good afternoon. My name is Sky Pike. I'm a member of the Innovation Advisory Team here. And I'll be monitoring our time here today. I'll be kind of the host, more or less. The session is being recorded for future use, and it is my great pleasure to introduce, I should say, my friend Felix Amissah, who is a researcher over in pharmacy and the pharmaceutical sciences. And he is going to be talking today about the suppressing tumor growth to prevent lung cancer metastasis. So take it away, Felix.
All right, thank you very much, Sky. So as Sky rightly said, I work in that area of testing some anti-cancer agents, trying to prevent the progression of cancers, especially with lung cancer. So I'm an assistant professor of pharmacology at the College of Pharmacy, just as an introduction to reiterate what Sky said. And today, I'm going to present part of the research that we've done and where we are going with this. So basically, what I'm going to do is to introduce as a form of background what we've been doing, and then chip in some of the aspect of the previous work that informed the current study. Whilst doing that, we are not digressing too much from our central hypothesis, which I would state, and then discuss the ongoing research work, and then we'll conclude, acknowledge some people, and take questions from you if you have any for me. So in the area of lung cancer, it is known that recent development or advancement in technology has helped a lot with the detection of lung cancer. Also, targeted therapy has also helped to improve the treatment of primary cancers. So when caught early, lung cancer can be fairly treated. And if it is localized as a primary tumor, which means if it's localized within the lung tissue, surgical resection can remove it, and some chemotherapy will be very successful in treating the disease. However, most people present lung cancer at a very late stage. And we know that nobody gets out to go and screen for lung cancer unless they suspect there's something wrong. Eventually, we know that most of the time, by the time we detect lung cancer, it has already spread to other tissues. And that is the condition we call metastasis. So primary tumors can fairly be treated, but when it's metastasized, most of the time, it's very difficult to treat. And 90% of lung cancer-related death is associated with metastasis. So metastatic disease is what keeps on driving the survival rate of lung cancer to abysmal level of 5%. Also, when the lung cancer has metastasized into other distant tissues, it is likely that after treatment, it will rebound, or should I say there will be recurrence. So in non-small cell lung cancer, for instance, about 45% of the cases we see recurrence occur brain and the liver. So simply illustrated, it's as if normal cells eventually become cancerous and then it metastasized. The steps involved in metastasis is very detailed, but let me summarize the steps involved quickly here because you need to understand what we are doing in the lab. Primary cancer within the lung can metastasize to distant organs like the liver, and that's the secondary tumor, okay? But there are several steps involved. The primary tumor would normally be growing, the cells will be proliferating, we have some markers to tell that the cells are surviving and proliferating, like BCL-XL expression of those proteins tells us the cells are proliferating. And then when the cells are proliferating and the tumor is growing, in order to meet the metabolic demand, the cancer cells are able to induce new formation of new blood vessels to supply their needs. And that is a process called angiogenesis, okay? And then eventually the cells acquire a property that allowed them to move into the bloodstream and then be carried to distant organs. And the detachment is made possible because of expression of certain proteins. And that process is known as epithelial mesenchymal transition. And it gets into the bloodstream through intravasation, migrate, get adhered into the vessels, and eventually when they get to the target organ, they extravasate and start growing within the other organ as secondary tumor. These processes can be targeted, and part of what we are doing is to target this process, because if you're able to contain the spread of the lung cancer, then you can surgically resect it, and then because it's not spread, it will be easy to treat. So we found out that certain proteins are involved in almost all the steps involved in the cancer metastasis process. These proteins, we call them Rho family of GTPases. That is Ras homolog proteins or related proteins. These act as molecular switches, exchanging GTP with GDP and becoming activated. When bound with GTP, they signal through several proteins to activate cell growth, division, differentiation, and other things. Some of the actions of these GTPases include cell proliferation, invasion, metastasis, changes in the nature of the cell so that they can migrate, new blood vessel formation, and then they are able to resist treatment, reduce apoptosis, and the cancer cells can undergo abnormal metabolism, which would all feed into tumorigenesis, cancer cell progression. Now, there are key types of these Rho GTPases which have become mainstream agents that drive this process, and that is where our focus is going to be. So we'll gravely focus on the Rho A, RAC1, CDC42 proteins. And for now, what we've been doing in the lab is to study their involvement in cell proliferation, invasion, metastasis, and then changes from epithelial format to mesenchymal state so that they can migrate. Well, how did we get here? It is based on our previous studies. Based on our previous studies, we see that when we combine some fatty acids with cyclooxygenase inhibitors like diclofenac and fatty acids like docosahexaenoic acid, we are able to interfere with the key canonical pathway involved in cancer signaling. So the Ras superfamily of GTPases, of which the Rho proteins also belong to, is known to signal through two major pathways: the RAF MEK-EC pathway to induce proliferation, and PI3K pathway through AKT to induce survival and inflammation of the cancer cells. We, from our previous studies, have found that if we're able to combine docosahexaenoic acid and diclofenac, we are able to interfere with this pathway. And because of that, we are able to reduce cell proliferation, reduce survival and inflammation. Now, through that studies, we also came to find out that not only are the downstream signaling of RAS blocked, but also the expression of the RAS protein as well as activation of RAS was blocked by the combination of these agents. So we analyzed the expression of the RAS protein, and we found out that not only are the isoforms of RAS being downregulated by the treatment using the two agents, but also the RAS homologous analogs of proteins, which are also GTPases that drive metastasis, is also downregulated. One of them is RAC1, as you can see over here. And that got us thinking that, is it possible that when we combine these agents, we are able to contain the primary tumor and prevent it from spreading? So we went ahead to test this by looking at these GTPases in other cell lines, not deviating too much from our central hypothesis. And our central hypothesis is that when we combine inhibitors of cyclooxygenase like the NSAIDs, example being diclofenac, it's able to preserve polyunsaturated fatty acids like docosahexaenoic acid. By so doing, we are able to dysregulate monomeric GTPases, of which RAC, RAS, RHO are part of. And if you're able to do that, we can kind of inhibit the tumorigenic process. So we went ahead to test this RHO GTPases after exposing cells to a combination of docosahexaenoic acid and diclofenac. And henceforth, I'll call docosahexaenoic as DHA and diclofenac as DCF, okay? So there's our polyunsaturated fatty acid, and there's our COX inhibitor. We found out that when different cell lines like A549 lung cancer cells, H1975 lung cancer cells, H1299 lung cancer cells were plated and exposed to DHA, they are able to reduce the expression of RHO-A protein, RAC1 protein, and CDC42. These are the key RHO-related proteins. However, when we combine it with diclofenac, you see that we're able to greatly reduce the expression of these proteins in cells. And this we quantified down here by the graphs below. And it's not only in A549 cells that we found that. In H1975 cells, we see that the combination was more potent at reducing the levels of these proteins. That got us interested. But even if little amount of these proteins are left, they can still be activated, bound to GTP, and signal, inducing the invasive properties. So I wanted to find out whether the combination is also able to limit the activation of the RHO GTPases. So we did that, and in A549 cells and 1975 cells, we see that exposure of the cells to DHA and diclofenac greatly reduced activation of the RHO GTP. So this is the total RHO protein, which the level has been reduced upon combining DHA 10 micromolar and DCF diclofenac 25 micromolar, low dose diclofenac. Activation was greatly reduced when we treated the cells with the combination. That tells us that DHA combined with DCF greatly reduced activation of RHO GTPases. That is great. Now, what is the implication of this in the cancer cells? What is the implication? We know that the key role of GTPases is to play a very vital role in cytoskeleton organization. So we wanted to find out whether this happens in cancer cells, and we use A549 cells. So the control cells, after 48 hours of treatment without anything, we see that the actin cytoskeleton that is stained green, the nucleus is what is stained blue, in the quiescent cells are quite prominently well organized. DHA was able to induce some changes, but when we combine diclofenac to DHA, we see rounding of the cells and disorganization of the acting cytoskeleton, which means that these GTPases are being affected by the combination treatment. And we even see at the higher concentration of the combination, we see rounding of the cells. And there's no way these cells can migrate if they are rounded up like that. They are almost about to die. Well, so what would this mean when the cells are supposed to move and invade distant tissues? We went ahead to do some migration assay. And in this case, we plated the cells in a monolayer, created a wound. So at time 0, we have our cells plated, monolayer formed, and then the wound created. And we monitored this wound over a period of 24 hours. So the control, we didn't treat with any compound, but the other test compound we used were diclofenac alone, DHA at very low dose that does not kill the cells, and then combination that will not kill the cells. And as you can see, after 24 hours, the wound has closed in all the cell lines that we use. So A549 cells, H1975 cells, A1299 cells. So when not treated, the cells are able to migrate to close the wound. However, exposure to diclofenac and DHA were able to prevent the wound closure to some extent. But when we combined the two agents, we see that the wound was not closed. And because of that, our conclusion is that the combination is able to prevent the migration of cancer cells. If you're able to prevent the migration, then invasion to nearby tissue will be limited. However, we need to confirm that. So we conducted invasion assay, because there's a quantification of the migration assay. The distance of migration and the number of cells in the migrating area were all reduced. So invasion assay involved matrigel-coated wells. We plated the cells in there, and we put some FBS in the lower chamber to attract the cells to be able to invade the matrigel and go into the lower chamber. And after 24 hours, we looked and stained, fixed the cells, stained them, and then analyzed the number of cells that were able to invade. Cells that were not treated, the control cells, were able to invade the chamber to larger extent. DHA exposure reduced the number of cells that were invading, but the combination was able to kind of increase the, or should I say, limit the ability of the cells to invade through the matrigel chamber, the matrigel, okay? And that is what we have captured over here, and we quantified and we saw that it was quite significant. Now, it is one thing preventing the cells from invading. One other thing that we found was that these compounds were able to prevent the changes, the transformation that gives the cancer cells invasive property. And that's what we call epithelial mesenchymal transition. There are certain markers, there are certain proteins that the cells express that shows that they have changed from the epithelial polarity or polarized form that is situated on the basement membrane to the mesenchymal form that is able to migrate. So these proteins include N-cadherin. So in the control, we see increase in N-cadherin, but treatment reduced this protein. E-cadherin is low, but treatment did not affect it much or even increase the E-cadherin. Now, fibronectin was reduced, vimentin was reduced. So all these are markers of epithelial mesenchymal transition, which was reduced. So in conclusion, we say that this treatment reduced the transformation from epithelial nature, so it inhibited the invasion and migration of these cancer cells. In conclusion, we see that combining diclofenac with docosahexaenoic acid was relatively more potent at reducing the levels of GTPase and its activation. It disrupts cytoskeleton organization prevent the cancer cell migration and invasion, and reduce epithelial mesenchymal transition. What does it mean? Well, under normal circumstances, cancer cells would switch from the epithelial basement hooked nature to a form that is able to migrate. That is the mesenchymal type. When we treated or exposed those cells to polyunsaturated fatty acids and diclofenac, this process of EMT was reduced and subsequent properties of the cells were affected. And because of that, migration and invasion did not take place. And this is because we've already shown that the signaling that induced EMT was blocked by the combination. That is, AKT signaling was blocked. And the Rho GTPases, which are able to play major role, were also either reduced or inactivated. Now, this is interesting in the sense that
you have we really have only a little time left.
Okay,
So I need to wrap it up.
I'm wrapping it up. This is my last slide. So this is very interesting in the sense that it means low dose NSAIDs with polyunsaturated fatty acids can prevent spread of the cancer from the primary site. And that is what we are looking out for. Well, these are my references, and these I would like to acknowledge the College of Pharmacy and the Office of Sponsored Research, as well as College of Medicine at Central Michigan University. My external collaborators include Rosemary, who is at Central Michigan University, and Jamie, who is at Michigan State University. The students I worked with on this project, or I'm still working with on this project, are Megan Van Baren and Joshua Matson. Well, I'll pause here and take questions from you.
All right, we have about 3 to 4 minutes for questions if anybody has any. So do you want to exit out of the presentation there, Felix?
Okay.
Thank you. Any questions for Felix?
I can ask a question. So let me turn it on.
Sonali?
Yes, hello, everyone. It was a very nice talk, Felix.
Thank you.
So for the, since diclofenac plays a role with overcoming the resistance, especially with the epithelial to mesenchymal transition step, have there been any analogs of diclofenac that are being pursued? Or any structure activity relationship around it that
yes, there are. That's a very good question. So, that is actually where I'm going. Diclofenac itself has been touted to be very toxic, and that is very true. However, NSAIDs in general, we are already using them. Some group have found out that it is the R isomer of the NSAIDs that really interfere with the GTPases. But we are interested in the whole structure because the S isomer is responsible for inhibition of cyclooxygenases, which can also signal through the NF-kappa B pathway to kind of prevent the inflammation associated with cancer. So using low dose would be the way to go. But structurally, it's the R isomer which is involved in the interference with the migration and invasion. Yes.
Okay, thank you. I mean, that's the reason I was getting at it is perhaps there could be better analogs than diclofenac or new analogs of diclofenac that could be better perhaps at this step. So that's what I was getting at. But it was an interesting talk. Thank you.
Thank you very much.
We've got a couple minutes yet. Are there other questions? Oh, I have one for you, Felix.
Okay.
So
thank you all for listening to me.
You're dealing with PUFAs and you're dealing with COX inhibitors.
Right.
That suggests that there's some type of potential role for prostaglandins or other endogenous cannabinoids or molecules derived from the PUFAs that may be playing there. Do you know of any mechanistic interactions there that are going on?
Yeah, in fact, a lot of, when it comes to polyunsaturated fatty acids, there are a lot of mechanisms that have been proposed. And we believe that all these mechanisms come to play. Now, yes, we know that prostaglandins are overexpressed in cancers. So if you're able to, like, especially prostaglandin E, so if you're able to kind of prevent the production of prostaglandin E, you are likely to prevent the inflammation that's associated with it. But now we know that the cytochrome P450 pathway also plays a role. Resolvins and marasins are also have been implicated. So when it comes to the polyunsaturated fatty acids, it's a wild field. But we are trying to focus on some specific areas that people have not explored much. And if we're able to kind of know there is that protein that is involved, that plays a major role with this combination, then we are going to switch totally from the molecules themselves and target that protein. So that's where we are going with this. Yeah.
Thank you. Nice talk.
Thanks.
Well, we are really at